Did I what? Was there a 101? Did I open up? Oh, I opened up pre-cals, not honors pre-cal. My bad. Because your assignment was a little different. Was it longer? Did I just open up the wrong one again? Pre-cal. Oh, there we go. Happy Friday, cool kids. You guys ready for the weekend? Is it a normal weekend? Anything abnormal going on? You have the game tonight. I don't think we have any meets or anything this weekend, right? Is this better? Aha! On RedWeb? It clicks to the link for your... You mean Google Classroom?
No, I got 98.101.
You put 93? Huh, I'm confused. Kyle, did you go from the class notes? Like, did you go from the website? You went Google Classroom? He got 101? How many people wrote down 101? 98, 101? Oh, I don't know what happened. Sorry, guys. Robbie, I don't know where you're looking, bud. You're in the right Google Classroom, though, so I think you're okay. Okay, sorry. Number 2 was notation. F inverse. Number 4 was the identity function, y equals x. Number 14, you guys hopefully got down to x for both. Number 20, did you graph the inverse properly? That one was a little bit hard. You had to kind of flip piece by piece by piece. But that would have been the inverse graph. Number 26, did you guys get that it was its own inverse? And when you do 1 over 1 over x, what do you get? Well, 1 over 1 over x, don't you just reciprocal it? X. And then how does that make sense with the graph? Isn't it its own reflection already? It's already its own reflection. It doesn't have anything else to reflect or any other function to get. Number 42. Was it invertible? The answer was no. Why? Because it fails the horizontal line test. So it does not have an inverse, and technically it should have kept going inverse function. It doesn't have an inverse function. Doesn't mean it can't be undone, but it would need more than one function. Number 52. Once again, it was its own inverse. When you switch the x and y and solve for y, the graphs are the same because it is its own reflection already, kind of like the other one that we already saw. Domain and ranges. Both of them are all real numbers except for 0 because there's a vertical asymptote at 0, so x can't be that. There's a horizontal asymptote at 0, which isn't the reason why, but the graph doesn't ever cross through it. So y can't be 0 and x can't be 0. Did anybody write those in intervals for the domains and ranges? Nobody did? Did you guys use a little like not equal to sign? Okay. Okay. I was just checking because we could show it in intervals if you wanted to. Number 64, did you get the plus or minus? Therefore, it's not invertible. Plus or minus, like yesterday. Square root of a squared is an absolute value. You need the plus or minus. Not just one function. Number 98, the graph does not pass the horizontal line test. Why? Is that the only table that they gave you on 98?
Yeah, you had to make the second table.
Oh, it was your responsibility to look at it? Because that little table right there doesn't prove it. That's why I'm like, what? Oh, 98. Where does it fail? You guys saw it, right? Yeah, it fails right there. In between -4 and -2. You can't really see that here, though. That's why I was a little confused. Well, I guess... Well, actually, no, this is a good thing to talk about. There is something called the intermediate value theorem that we will talk about at some point. But the function, well, there's going to be a lot more detail. I have to talk about this word called continuous and whatnot. But if it goes from all the values 3 to 4 and then 4 to 0, do you guys see how, even though we can't see it in the table, if this function is connected, and we call it continuous if it's all connected, if it has to go from 3 to 4, and from 4 to 0, doesn't that mean it's going to be crossing through y's twice? Does that make sense? Like it's going to have to fail the horizontal line test. So that's kind of tricky how the table shows it. It actually kind of does, but not very nicely. Oh, that's the last even. How'd you guys do in checking in your groups? Match up? Any evens that we didn't match up on that we need some clarification on? Sorry. Thank you. Yeah, Gavin. 98 was asking whether or not it was invertible. If we check this, it says to create a table of values, then create a second table of values that can be used to find F inverse. What they were saying was, if you were supposed to find the inverse of this, it could be really tricky to reflect it, right? Because, I mean, that's complicated. So they were like, maybe it's not going to be easy just to reflect the picture. Maybe you should actually, here's what the table does, look at the points. So they said go ahead and write down the points like -4, 3, -2, 4. They said write down the points. And then how can you make a table of points for the inverse from points of the original? Switch the x and y's. Good. Switch the x and y's. And when you switch the x and y's, then it said sketch the graph of F inverse. And somewhere in here, I guess they didn't specifically ask whether or not it was invertible. I just kind of took that extra step and said, hey, by the way, it fails the horizontal line test. The original does, which means when you graph the original, it fails the vertical line test. So technically, to be honest, Gavin, I think that the answer key didn't do a good job of answering the question. According to how I read it, and you guys can say whether or not you agree or not, you should have had a graph, shouldn't you? Okay, so with the graph, what points did you guys get for the inverse? If the original was -4, 3, the inverse has 3. Okay, so you should have a point right there. And then if the original has -2, 4, 4, -2. Right there, I already fail, right? I already failed the vertical line test. We can keep going. 0, 0 is still 0, 0, true? And then 3, -1 becomes -1, 3. So then you can kind of see how they connected it with lines. There you go. And that should have been the graph of F inverse, with probably a little table. But why can't we call it F inverse of x? And this might have been why they said what they said. You could have taken the points. You could have switched the x and y's, but what could I not call it? Yeah. If I did call it the inverse, guess what? I would be wrong. Why? This is the inverse function, and what is this not? So that's, I think, why they went ahead and said, oh, wait, the original's not invertible, so we can't graph the inverse function. We can graph the inverse relation, but not the inverse function. Does that make sense? I think that's why they answered it weird. Okay, sorry, those were questions on the evens. Any questions on the odds? Yeah. 101. Where's he at? Oh, there he is. Think about it. Do you guys like thinking about it? Some say yes and some say no. Some say yes as long as you don't have to actually be held accountable to it, huh? The function f equals k. Who's k? What is that guy? What do you guys think k represents? Is he another variable like y or z? No. He's just kind of like an arbitrary constant, meaning he could be anything. He could be 2, he could be 5, he could be 7. Oh, hey, he's an unknown number that we're trying to find. Okay. So f of x equals k times 2 minus x cubed has an inverse function, and f inverse of 3 equals -2. Huh? Come on, someone amazing. How did you use this clue? I would call this a clue. In calculus, I'd do the whole Blue's Clues. It's like, hey, it's a clue. Maybe you guys are getting to where you didn't watch Blue's Clues. Did anybody watch Blue's Clues when they were younger? How many? Raise a hand. Oh, I can still use it. Okay. So this is our clue. Put it in your handy dandy notebook. Okay? So we have our clue. How do you use that? We technically have 2 clues. So f of who would equal what? So doesn't that mean I can say of f or for f, I have the point x equals -2 and y equals 3? So couldn't I then go ahead and say, oh, sweet, well, if that's my clue, I can go ahead and take my function f of x and say, hey, buddy, you're supposed to be 3 when x is -2. Right?
Yeah.
Taking the inverse, flipping the x and y, and saying, oh, cool, I have an x, plug in, I have a y, plug in, dun, 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 solve for k. So I end up with 3 equals k times 2 plus 2 minus -8. Ooh, got to be careful of your PEMDAS and your signs.
Oh, no.
And don't we get 12, and then we divide by 12, so k equals 1/4, 3 over 12 reduced. Does that match up with what it's supposed to be? Does that make sense? Tricky, tricky, tricky. It gave you a clue for the inverse function that you had to then relate to the original function and then plug in and solve. I like that problem. Maybe that's why I assigned it. Okay. Anything else? Odds or evens? Going once. Going twice. Sold. Jason, since you stepped out, did I get your corrections for your quiz yet? Yeah, go ahead and get them ready for me. It's okay. Stapler's at the front. Kim. No, I haven't. Let's go back and peek at 73. All right, last question, 73. And this was from the long, paragraph of directions. There we go. But I think we did an example like this somewhere towards the end of class yesterday, right? Plus or minus, what? Okay, 73. Restrict the domain. It's tricky. Thank you, Jason. Restrict the domain. It's tricky. What is it saying? It's saying, hey, by the way, this guy fails the horizontal line test. And do we know that just by using section 1.7 and saying it's a parabola shifted left 2? Wait, is it left 2? No, because horizontal is the unexpected. So the minus is actually shifting him. A scribble that erases. It's weird, I know. Right 2. True? Okay. Does he pass the horizontal line test? But what does it tell me to do? Cut it down so that it does work. And yesterday, what did I say in the notes about how to cut it down? Yeah, we're trying to figure out a domain. We're trying to restrict the x such that the y's are all still present. So guys, how many y's are there right now? What's the interval of y's, or the range of f of x? 0 to positive infinity, or y greater than or equal to 0. So I need to make sure that I still keep this range the same. I still have 0 to positive infinity, but cut down the x's so that it will not fail the horizontal line test. What's one way of doing that? Take half of it. Which half do you want? The positive half or the going negative half? The principal one, which is the main one that we should choose, is always the one going positive. So I'm going to agree with you and say x is from 2 to infinity. But if you had said negative infinity to 2, you technically wouldn't be wrong. It just wouldn't be... Remember yesterday how I had you plug in the sine inverse one? And it got 30 degrees? But I was like, hey, there's infinitely many answers, because it could be 30, or it could be 390, or it could be, you can spin and land and spin and land and spin. They're called coterminal angles. Anyway, there are infinitely many answers, but your calculator gave you 1. If the calculator or the programmers were doing this, they wouldn't choose this as the 1 answer. They would choose that branch as the 1. So this is the best answer, but you could have also done the other without knowing the best answer, and that's okay. What does it say? State the domains and ranges of f and f inverse. This was f. And if we cut down f, what's f inverse is going to be? All you got to do is switch them. So the x's are 0 to infinity, and the y's are going to be 2 to infinity. And similarly, if you had done negative infinity to 2, that would have also been okay. State the domains and ranges, explain your results. Just say that you were cutting down the graph to not fail the horizontal line test. Is that okay? Something like that? Okay. All right. Let's go ahead in section 1.10. If you guys look at the backboard, our main goal today is word problems. Specifically, variation. What are all the different types of variations? And how do we read a problem, interpret what's going on, translate the words to mathematical expressions or equations, and then solve if we're asked. How do we interpret, translate, solve? So here we go. Oops, that's not. what I want. That's not what I want. I actually did want that still open. This is what I want. Got it. So yesterday we started writing, but we didn't get very far, true? Today I was going to have the notes open, but then a couple things slowed me down from last class. I do apologize. We got this page already, right? Okay. I'm not going to have you take this page. I was just trying to show you where homework starts, and where homework starts is a lot like, where homework starts is a lot like, go away. Okay. It's a lot like calculated worksheet number 2. So remind me really quickly, how would you do a problem like that? Go to your table. How do you find your table? Oh, second graph. That's where the table is. No, don't call it a table. Where do you go? To your, what are they called? Not tables, but? Okay, you go to the stat menu, and what are they called? What are you editing? What's L1, L2, L3 stand for? Lists. Lists. If you say go to your table, a lot of people get confused and try to go to second graph, and that's not going to help them. So go to your lists. Good. How do you go to your lists? Don't you hit the stat button, right? And then you hit edit. How do you run a regression? Least squares regression, same thing as a linear regression. Stat, calc, go over to calc, right? Stat over to calc, and then you can run your linear regression. Does that make sense? What we didn't talk a long bit about yesterday is this very bottom part, which I don't think you'll need to memorize at all. But the closer R is to 1, the better the fit. So those of you guys that see the correlation coefficient, that see the R, the closer it is to 1. If it's like 0.5, it's like meh. If it's 0.2, it's not so good. If it's 0.8, 0.9, it's looking pretty good as far as fitting the data pretty well, being a good model. But anyway, running a regression, we talked yesterday about how you're going to plug these data points in not as 2000s, but as years from 2000. Plugging in your points. What's that really cool zoom that helps with stat plots? Zoom stat. And how do you turn on a stat plot again, if you needed to? Second y equals, you can turn it on there. Or can't you do y equals up for the newer calculators? Plot 1, plot 2. Okay, all that's in your handbook. Quick reminders of just where it is, how to get it. So you guys shouldn't be totally shocked when it's like, oh, this is a thing. You can do a stat plot and do a linear regression and then see how to fit this data or how to predict the data, etc. Let's move on. Let me go ahead and, I know it's going to be a little annoying. There are a lot of words. Let me get this up on the screen. Let me bring it down so you guys can see the whole thing. I'm going to turn off the lights so you can see it a little bit better. I know it's kind of hard with the lights on sometimes to see what's going on. Let me pause the video so you have a little bit of time to write. Okay, so the first one, direct variation. Directly proportional to or direct variation. Let me get my colors out. And let's go ahead and zoom in. So, nope, that's inverse. Here we go. Y. If you guys are looking at each of these statements, the y comes first, right? And we talked about earlier this year about how you won't always be dealing with y. So for example, or for instance, in this first example, what comes before the is directly proportional to? Simple interest. So simple interest would be the independent? No, the dependent. Y is dependent. The dependent variable. Could we call it y? I suppose we could. But do you think the book's going to be calling all of these y's? The answer is no. So what's another variable that we can use for simple interest besides y? X? I don't know if you want to use x or y. P? We could. Why are you thinking P, Kyle, and not S or I? You don't know, just because? I'm going to do S for simple. Why would I do S for simple? Actually, no. In math, I was going to do S and then make it this whole thing, but let's not. In math, interest is almost always going to be I. In financial problems, where you're talking about money, interest is almost always I. That's going to pose a little bit of a dilemma, but that's all right. We'll deal with it. Kiddos, what goes second in all of these statements? X. So I have X is after, varies directly. X is after, directly proportional to. X is not right there. X is over here. Right? What comes after the word is directly proportional to in this example? Okay. The amount of the investment is how much money is put in, and if anybody remembers anything to do with interest, that's almost always called P for principal. That's almost always called P for principal. Interest is almost always called I, and amount of the investment, how much money you're putting in, is almost always called P for principal. So then, I mean, literally, guys, it's as easy as, look at this equation. This is how you translate the words into the math and say, okay, fine. So I is equal to K times P. That's how you would translate, using the phrase directly proportional to and getting your variables. So one step in these word problems, when you read and interpret, trying to translate what's going on, is going to be establishing variables. Oh, I didn't mean to dual page, I'm sorry. Is establishing variables, who are all the different key players, figuring out the relationship, making an equation. Now sometimes that's the end. Sometimes they say just translate, you're done. Sometimes you're going to have to use it to solve. We'll get there. Second example, who comes first? Distance. And they even in this one don't give you an option. Distance what? Distance S. Okay, it is what it is. What comes second? Yeah, you got to read the entire thing. Square of the duration T, T for time. So then how are you going to go ahead and set up this equation? Oh, I thought you guys would have it. How would you set up this equation? S, because it's the Y, right? S equals K times what? T squared. Good. Okay, it's as basic as that. Translating the words into the math expressions. So directly proportional, this K is a constant. Depending on the example, it could be something like pi, it could be something like E, it could be something like -3, it could be all sorts of different constants. But we're just setting up what's going on as far as the relationship between the Y's and the X's, the dependence and the independence. Now on this page, I'm going to do something really similar. Because as you notice, each of these phrases has a Y coming first, right? And my equation does too. And each of them has another quantity, which they call X, whatever, sure, fine, coming second. You see the division for the inversely proportional to. So as you look down at your example, if we're trying to think of making a model from the words, what's your first quantity? Demand for a product. You could do the entire thing, but what's the main idea? Demand, right? And then what comes second? As the price of the product. So we could call it, I don't know, what do you guys think? P? Is that okay? Demand and price. So as you go ahead and set up your equation, what you going to have? D equals K over P. Now, guys, are you seeing the word is? Not always, so you have to be careful. But look out for these new things like varies inversely. You might have an is, but you might not. Just keep an eye out for the different words. Okay? So then, is there any other type? Are there any other types of variation? And the answer is yes. There are two other types. Let me go ahead and get those up. And once we have these, we're good to go. Okay? Hang in there. Once we have these, we're good to go. We have combined variation. Oops. And we have joint variation. Just one. Just one. No, hold on, wait a minute. The words just got a whole lot longer. Pause. So will they in homework. So let's think strategically. If I allow you to shorten and to just pull out the main pieces of information, right? And writing directions and problems. What's the main pieces of information? Try to write down the main pieces. Don't tell me, but write down like you would in homework. What are the main pieces of information that you need? Because for actually solving the problem, you might not need everything written down. You need the key players, who they are, and their relationship. Is it cold? Sorry, I'll close the door. You guys close? We have a little bit more time if we get to this page if you don't have it yet. Let's go ahead and zoom in on the first one. Okay. So what did you guys pull out as the key players? Did anybody pull out the Y? Who's the Y? Resistance of a copper wire. Good. Resistance. If you were really caring about the idea, the electricity, what's really going on in the problem, yeah, maybe you would write down something about the copper wire carrying an electrical current. But what's the main variable? Resistance. Everything else you can tell by prepositional phrases, you can tell by the descriptors are describing the resistance. The resistance is the main idea. Okay? Who's the X? Ah, do you see how we have one relationship here? And what is it is directly proportional to? Length. But what else do we have? What other word? And inversely proportional to. This is what is called combined variation. There's more than one thing going on. So we have resistance. We have resistance being directly proportional to one guy, and then we have him being inversely proportional to another guy. So then, well, but if it's and, guess what? It's all at the same time. So one equation still, can we call R resistance? Is that okay? Directly proportional, can we say K times, now here's where it gets a little funny. Ready? We can say K times length. Got that? But inversely proportional would say the same K is being divided by its cross-sectional area. So in essence, we can really just say R is equal to KL A. And I have the relationship of K being directly, or I should say R being directly proportional to L and inversely proportional to A, all at the same time. And sorry, that's an R. If it doesn't look like an R, I apologize. There you go. So that's combined variation. You might have direct and inverse going on at the same time. Make one big equation. Just keep in mind who's the Y and then who are the independent variables on the other side. Cool? Okay, so what's joint variation? There is a new little formula for him. Now let's see, it's a little bit weird because now we have like a new guy. Now we have a Z. But I'm still going to make him purple just because he's still technically the dependent guy on the left-hand side of the equation. I just have over here, I have two different guys. I have X and Y. X and Y. And if you check out the equation, X and Y going together. So what if a quantity is directly proportional to more than one thing in the exact same way? We can call it joint variation. Or if it's, in a sense, directly proportional to both, well, we can put both down there. So as you guys were writing this example, hopefully you realize the main guy here is kinetic energy. Yes, if you're trying to understand the problem of an object, but the main guy that's just describing of an object is describing E. And jointly with, so there's your wording. There's no is, but that's okay, we're fine. And jointly with, we should already expect two different things. So we have the mass, and we have what? The square of its velocity. Ooh, the square of its velocity v. So how can we translate that? Okay. Got it. Does that make sense? Well, technically, PEMDAS would say, you could put parentheses around the V. Technically, though, it's redundant because PEMDAS would say that the square goes first anyway. Let me undo real quick. So PEMDAS would say square the V, then do times M times K. Or technically square the V, K times whatever's left. But good question, Robbie. So what happens if we get to something like this? And it says, hey, by the way, we'll tell you that you need to do this translation, but then you also have to keep going and not just translate, but also solve. Not just translate, but also solve. So give us clues, x equals 4 and y equals 8 pi. They give us this little translation-y thing down here and says, hey, by the way, y varies directly to x. I'm going to have to do all sorts of stuff in this problem. Because I can't even think about using the 4 or the 8 pi until I have a model, until I have an equation. So what equation do I start with? Based on the wording. Equals. I heard it, k times. So I have to get the model first, and once I have the model, then I use it. Well, how do I use it? Plug and chug. So I can say, okay, now I have these clues up here, so let's go ahead and use them. So 8 pi is going to equal k times x. Ooh, who is x? 4 when y is 8 pi. Why? Because now I can say not just what the general model is, but for this data point, well, it's not just any k. It can only work if k is 2 pi. Hey, by the way, it looks a lot like circumference, but they didn't tell us that specifically. So we'll just use a general y and a general x. We don't know exactly what they're talking about. But circumference has a directly proportional relationship between circumference and radius. Now this one's pretty easy because it just says, oh, hey, by the way, words lead to model, model, use points, plug in, have a specific, not just a general, but a specific model. And we could use the specific model to predict things. What would we do with this one? Maybe, I mean, you could graph it and see if it looks like a line. because that's what this is. This would be a linear. This would look like the other guy, the swoop, there he is. He'd be more swoopy. So I guess you could graph the points, but what's another way that we could see whether or not this is more of a direct relationship or an inverse relationship? They give us points. They say it's either direct or inverse. They tell us to solve. Couldn't we test some stuff and see if it works? For instance, couldn't we maybe plug in when x is 5, y is 2? Find the k, what the k would have to be, which is 2/5, right? And then couldn't we say, well, okay, this better work for another equation or else I'm in trouble. So what if I use 2/5? Would it work for another point? Well, what's another point? Let's use 10/4. When x is 10, y is 4. True or false? Well, that would be a 1, that would be a 2. Hey, does 4 equal 4? Well, let's think about the line versus the swoop. Linear. Slope, rise over run, always constant. The swoop, there it is. Does he have any linear portions? No. So you could keep going, you could keep checking it out, but you could also see, wait, every time the x is increasing by 5 and the y is increasing by 2, this is a linear relationship. The rise over the run is the same every single time. So therefore, which one is it? Sorry, I didn't actually answer the question. If we had tried plugging into that one, it wouldn't have worked. It would have failed on the next point. But then it starts to get a little bit weirder. Then you start to get some words. Okay? But with the words, you just have to think about, as you're doing homework, picking out your different guys, your different pieces. When you pick out your different guys, your different pieces, assigning maybe variables to help you out a little bit. Some of them we will have used before, some of them we won't. But you'll be making equations first, but instead of using y's and x's, maybe you'll be using different variables. But then you're going to be plugging in different pieces of information. And when you plug in different pieces of information, you won't know k right away, but you can find it. And once you find k, you will have a nice, solid, specific equation that you can use to then go find other data points, similar to calculated worksheet number 2. But instead of just doing tables, just doing regressions, you're going to have wording leading you to equations. Think you guys can try it? Read, break it down when you write down your problems in your book or in your homework spirals. Find the model that they want you to use, plug in any clues, and then see if you can make it specific and then use it if they ask you to. All right, cool kids, get out of here. Have fun interpreting, translating, and solving this weekend.